So yeah, so if anyone's on the Zoom, let us know if that looks right, if you have the right view. Okay, and then there's a browser window, so.
And let's just go back and forth. Great. Okay, hi, I'm Dana Robinson. I'm the Director of Software Engineering at the HDF Group, and I'll talk about the state of HDF5. I'll talk about our product status, some work we've been doing with community engagement, and I've got a couple slides where I talk about some ideas for some future plans and things I want to work on in the last half of the year. So let's start with the release schedule. Latest release is 1.14.2. It's releasing this week. Includes in-place type conversions, selection IO with MPIO, the MPIO VFD. RS3 VFD now supports the temporary security tokens and a bunch of bug and CVE fixes. So now we're down to one known CVE issue remaining. I'll talk about CVE issues in a little bit if you don't know what those are. So then 1.14.3 will release in October. Let's see this thing, got this on the screen. This one. There we go. Okay. So yeah, we have a release coming up in October. That's going to be a release targeted towards the E4S release for the exascale computing project. That's their big package for their big package of all their ECP software. Should be CVE free. We've got the last one that we're just finishing up now. And the focus on that will be addressing any remaining HPC and exascale computing project related issues for the E4S release. And I haven't put the 1.14.4 release on the schedule yet, but that'll probably be sometime in the first half of 2024. So the 1.8 line ended in January with 1.8.23, and the 1.10 line is going to end soon at the end of September with 1.10.11. And then 1.12.3, I was hoping to get rid of that earlier in the year, but that's going to be in November. And that does end all those lines. So the only release of HDF5 that will remain is 1.14. But nobody should panic about that because it's a high quality release, it's performant, and you can pick whatever API you want using our API compatibility macro. So if you really need 1.6, that's fine. We have mechanisms for doing that. So there's no reason to really keep those things around. So here. Oops. Yeah, so Neil will go over the features that we have in there. Just as a quick reminder, what came out in 1.14.0 was subfiling, which is basically IO concentrators, multi-data set IO, which allows you to stripe IO operations across multiple data sets, selection IO, which allows you to pass, so it's at the VFD level, allows you to pass selections to the VFD layer, and then the onion VFD, which is version control, basically via the VFD layer. And the VFD swimmer project that we got that pretty close. It's still TBD. I would like to find some resources to finish that up and get that merged in. Now it's out of sync with the library by quite a bit, so that's going to take some work. For the few people who care about HDF4, we do still maintain that. That we just recently had a patch release of that fixes a critical Java issue that affects the HDF view. There's a few other minor bug fixes in there, and I made a few other build system improvements. And then next year, in February, that's the normal time we try to release HDF4. Sorry, let me go back. So earlier this year, we did significant code cleanup, and I overhauled the build system because people are complaining that HDF4 is not working with the newer hardware like Apple's M1 Silicon and things like that, because it had a lot of hard-coded things in it and nobody had updated it in a while. So I ripped all that out and made it look more like HDF5 to where most things are determined at configure time now. So it should be much more maintainable in the long run without us spending a lot of time on it, and include a lot of bug fixes. And just so you can see, I mean, we do try to maintain our software. I'm showing this not because a lot of people here care deeply about HDF4, but I do want to point out that when we said we were going to support HDF5 in the future, it's like HDF4. We will support this for a long time. This has been around since I was in high school with my Def Leppard posters on the walls and my neon phone. So we've been supporting this for a long time. It still works. It still works on modern computers. It's still maintained. And HDF5 will be the same way. And it can be used as an archival format, which is not necessarily true of some of these Johnny-come-lately file formats that I won't mention. So, so then there'll be another release in the spring. That'll be 4.2.17. Maybe it might be 4.3. I do want to have a defined public API for that. And I do want to remove the XDR dependency, because those are things that have driven me bananas as I've been trying to make changes to it. I'm not going to put a lot of work into this, but I do want to make sure that, you know, once a year we do get funding to support this, that we keep this moving along and every release has some improvements in it. And then the HDFU release schedule, I don't have a pretty plant UML graph yet for that, but I'll get one up there. The current version is 3.3.0 that came out in April. It's based on 1.14.0 and 4.2.16. The next version will be 3.3.1, which come out shortly after we get 1.14.2 out the door. And that'll be based on 1.14.2. and 4216-2. When there's delays in getting these things out, a lot of times it's due to code signing. Microsoft and Apple change the rules all the time. And so sometimes we have some problems with that. So apologies if we ever have delays because of that. Yeah, and we no longer maintain the versions based on the older versions of library. So there's versions that we used to maintain that were based on 110 and on 112, and we no longer maintain those. There's no reason for that. Good.
23 or 4?
Oh, sorry, 23. Sorry, my bad, typo. Yeah, 23. So yeah, about the release versions. So we post the release schedule on the readme.md on GitHub. So if you ever want to know an up-to-date version of a picture of when we think we're going to be releasing software, I keep that updated as I change my mind about when things are going to come out. As we schedule new releases, I immediately put that on GitHub within a day or two. We're trying to minimize the number of versions we support. Keeping a lot of balls in the air has been just, it's a lot of person hours to keep that going. And so I'm trying to cut that down so that we can spend more time working on the important versions that people are using. And these are often driven by features and key projects, but I'm trying to settle in on a schedule where HDF4 will be released once a year in the spring. We'll do 2 maintenance releases of the library, of the HDF5 library in the spring and the fall. And then we'll do HDF View, depending on how quickly we can get stuff automated. That one's a little harder to automate because you got to pull in all these binaries and stuff and do GUI testing, which is a little harder to automate. But that'll probably be 1 time a year after HDF4 releases. I'd like to get it every time HDF5 releases as well, but that's
milestone feature at all, user track releases?
I don't know. I don't know about that feature.
Okay,
Yeah. Okay, great. Yeah. And we'll talk about community engagement and doing stuff on GitHub right now. So one of the things that we started doing is we have an engineer of the week who is, I mean, this is inside stuff that inside the company. You guys don't really see this, but what you do see, I hope, is that people are more attentive to GitHub now. Is that we have a person every week that we rotate through, and their job is to monitor our key products like HDF5, HDF4, HDF View, HSDS. We'll add the plugins into this. I'm going to add the forum to this going forward. So just so that at least there's some background engagement all the time, that all the engineers in the company are paying attention to this stuff. So I'm hoping that people are seeing more engagement in our public facing things. We have an HDF5 working group meeting. Purpose there is to discuss HDF5 library development. It's not for tech support or the things like that. It's where we go over things like RFCs. We go over recent PRs, issues, discussions in GitHub. There's other technical development discussion. It's every Thursday at 10 a.m. Central Time, 10:05 a.m. because 8 a.m. is when my kids go to school. And so I need an extra 5 minutes to make sure that they get out the door. But it's open to anyone. Send me an email and I will get you an invite to the Teams meeting. We're trying to get some mailing lists set up so we can better coordinate this stuff. And this will eventually, all the discussions about this and will move to GitHub. I'll talk about that in just 1 sec here. So everything's moving to GitHub. So releases, we're trying to do releases off of GitHub. Bug reports should be entered as GitHub issues. We're trying to move existing Jira issues to GitHub, go through our backlog, clean things up, close things that are no longer valid. There are some things that have private data in them. We're not just going to move your private stuff off to the internet without telling you, about asking you first. We'll keep that stuff internally. New feature requests should go to GitHub discussions. There's a tab on the discussions page. But I'd like for the things that go into issues to be things that we can fix and close. Eventually I want to get our issue backlog down to 0 and maintain it that way. Support questions should go to either help@hdfgroup.org, the email address everybody's been using for a long time, or the HDF group forum. I'd like to encourage people to use the forum because the forum is nice because once you get your question answered, now everybody can see your question. It's searchable. And if you email the help desk, you also get an answer because you maintain that. But that only helps you. It doesn't help everybody else. I'd like for there to be more information out there about how to use HDF5. And then we're moving all the development documentation, like the working group notes and things like that, and kind of how to exist in the HDF5 ecosystem and work with us. I'm trying to move all of that to the HDF5 wiki. And that's just getting started. That's just a work in progress. And there's some things that I don't really have good solutions to. So if people have ideas for how we can do this, that would be great. If you notice that there are things that are missing and you've seen other open source projects do it well, things like code review. Right now, we do a lot of code review via pull requests. And that's just it's not a very good way of going over code. We used to use Crucible, but you have to have Jira accounts and stuff, and it might not be free. So trying to find good solutions to all of these things. And GitHub project management is a work in progress. We're trying to add people in as code owners. We're looking for people outside the HDF group to kind of take a more active role in HDF product development. I don't know exactly what this looks like right now. We're still working this out. I don't want to, I'm not your boss, right? If you're a volunteer. So I'm trying to figure out what's the balance between participation and, you know, some sort of control over kind of how we develop HDF5. We've added some people as external users to the code owners files. It's a GitHub thing for HDF5 and HDF4. Contact me if you're interested. If you want to take a more active role in developing the HDF5 library, and you don't have to know a lot about all the deep internals of the library. Just even people who are just good C programmers, having outside people come in, people who come from other from other communities, it's nice to have your input when we're developing features so that we can we can benefit from the experience of the community. And then, yeah, another thing is that aside from like the things like the binary compatibility, the file format compatibility, API compatibility, and so on, there are some gray areas that we've never really had a good way of addressing. Things like the build system options, tool options, the semantics of certain API calls and stuff. And so there's times where we want to change these things, and it's hard for us to know how to communicate with our users. I don't want to make a change and then have everybody scream at me that this was an unwise change. And so we're working on a policy for how to handle these things. I've already kind of baited it out in HDF4. I'm going to move it over to HDF5 soon. But basically, there's a document that before we make a change that faces users, we'll create a discussion post on GitHub. We'll create a sticky post in the HDF forum, and we'll make an announcement in the newsletter, and we'll let it sit for 30 days as we will bring it up at the HDF5 working groups and give people a chance to weigh in. And that gives kind of a venue for people to tell us what they feel about different feature changes and things like that. And we'll allow at least 30 days for comments, unless there's some kind of emergency where we have to make a bug fix. And so, yeah, I said this is on HDF4. I added in these new categories here. There's the breaking change and the proposed change, and then you can just add these things in. And people can do it for us too. Just show up if you have a proposal, use the little category there. This doesn't exist in HDF5 yet. I'll add it later, probably this week. And then people can ask for things to be changed. And then future plans. So what are we going to work on in the next half of the year? So I've got a couple of things on here. One is the taking security seriously. One thing I've noticed just over the past year, that there has been a big push to take security a lot more seriously in the past. And really it's been kind of ramping up to this, but I feel like now, like everybody cares very deeply. It seems like a lot of federal agencies are asking people to care about everything that's linked in underneath them. And so luckily we've been working on this for a while, and we just have a few odds and ends to clean up. I think we'll have all the CV issues under control. But I do want to take some more time to work on that. But then also provide the best possible HDF5 library for the final E4S release for the ECP project. I want to work more on making the RS3 VFD a first-class citizen. I feel like that's a key component of connecting HDF5 to the cloud. And then I would like to start discussing the next major features that we'll work on in 2024. So like I said, about this taking security seriously, I want to fix the remaining CV issues. I want to have the final releases of 110, 112 be CVE free. We have a CVE test repo that has the proof of concept files. They're all in one spot. They have a script that will go through. You can point it at a distribution of the library, and it'll run H5 dump over all the test files and make sure that they don't crash. Still needs a little bit of work. We're still missing some files. There's a Cisco Talos, when they have vulnerabilities, they don't give you proof of concept files. So I have to go in and kind of reverse engineer a broken file to make that work. I've tried contacting them and they don't respond. So if anybody knows people at Cisco, please let me know. Please contact me at this meeting. And but yeah, and then we need to specifically address the GIF tool issues, and it is pronounced GIF. And so there's these tools that you can use to convert HDF5 files to GIF files and vice versa. And there were some CVE issues filed against those. They're very old tools, not very commonly used anymore. Use GIF files, it's 2023. But we still have them in library. And so our fix for that was to disable them by default. So they still exist. We should fix the issues. But again, they're from Talos. I don't have proof of concept files. And I would like to, once everything's fixed, run the script via GitHub action to make sure that we don't regress. And then I also want to extend this out to OSS Fuzz. We started interacting with them. I recently became aware of the OpenSSF scorecard, and so we want to add, there's a GitHub action that we can add in for that. We'd like to restart the Coverity scans. We worked on those issues for a long time, but just to kind of take the security to the next level. During the last year, we have fixed most of the CV issues library. Like I said, we only have one of these things left. And so we've done a great deal of work. We spent a lot of time over the past year hardening the file IO level, which is where these things come from. They come from reading malformed files and then doing bad things because we read a 0 or it said there were a billion filters in the file and there's only one. And so it just happily sails off the end of a buffer. And so we fixed a lot of that stuff. So for people who don't know, CVE stands for Common Vulnerability and Exposure. These are actually tracked by MITRE.org on behalf of the US government and possibly other institutes. There have been about 60 filed against HDF5. Number isn't exact because there's some are duplicates, some aren't even really CVEs. Some are just like somebody said, we removed HDF5, so these things don't apply to us. And somebody filed that as the CVE for some reason. They're not really, it doesn't seem like they're very super careful about what goes into these things. But we track those. We've got a table. The 114 release does have this table in there. You can see an example over there, just the top of it. The ones that I don't have files for, we just list as untested. We list as failed ones. If it's blank, it means it passes. If we put pass in there, it clears the whole table and you can't see anything. So, and then there's one that is labeled NA, and that's the fake one. And there's links. Those links that are on there go off to the actual CVE page. They may break in the future. The CVE people, MITRE.org, they're switching to some new website. So we'll have to update that at some point. But right now they work. And then provide the best HDF5 library for E4S. So more ECP vol connector integration testing, like the async vol, cache vol, things like that via GitHub Actions to make sure those are all working. Fix as many parallel HPC bugs as possible. I want to get the HPC C- results linked off of the README page that you can go right there. In addition to seeing all our nice little badges and seeing everything that passes, you should be able to look and see is C- happy with all the exascale machines that we support, all the HPC machines. We have a vol test suite. We need to finish up some work on that. Better documentation of the ECP features. We'll talk about ECP features, and then some internal MPI related code cleanup. There's some things in there that we'd like to fix up that could be more efficient. And then the read-only S3 VFD. I'd like to expand that to Google and Azure and look at performance. Alexander's already filed a couple of issues in GitHub. We'll look at getting those things fixed. They're pretty easy to fix, the things that he's asked for. Maybe replace curl with the S3C library. Look at making the cloud optimized values the library defaults. Like that would be a nice change to have. It's not 1997 anymore. It's been 25 years. Update the HDF5 users guide to better tell people about how to work on the cloud. And update to use selection IO, better tool support, and then possibly H5 repack performance, because people are going to be, if you're going to put a lot of HDF5 files in the cloud, you need to repack them to the cloud native format. And then as far as future major work goes, that's the thing that we should discuss as a community, like where we're going to put our muscle behind and then go seek funding for it. So that's what these meetings are for. So we can have discussions. I have a whole slide deck full of ideas, and we can talk about those whenever anybody is interested. And then shameless plug for the European Hug, please come. I know it's only a month from now, but if you want to travel twice in the same 45 days, come on out to Germany. Hamburg is beautiful. I used to live there. What's that?
Is that hybrid?
I think so. Yeah. I think all of them are hybrid. Because not everybody, it's hard for everybody to travel to Europe and so on. So we'd like to always have it be inclusive for everybody. And then, our nonprofit mission that I will shamelessly plug and leave that slide up so you can know how to help us. And then, Neil.
You want to take questions?
Yeah, questions?
I don't know if you want to take it now, Dan, and figure out. You made a remark about code review and GitHub being difficult. It's a bit of a surprise to me, so I'm curious why. Again, you don't want to elaborate now.
Oh, it's just the code browser is very poor, right? Because you're looking at, it's like looking at the code through a paper towel tube. You only see this tiny little bit, and you can zip up a little bit and zip down, but you can't navigate. Like, so whenever I'm doing code review on something that's complicated, I have like my actual code open in the way that I normally develop, and then I'm looking at it and kind of going back and forth. But that's inefficient and not the best.
When you changes, like needs to go to that line, not just just over the whole.
Yeah. So it's not the best. I found Crucible to be, and Fisheye to be a lot better back when we had those.
There was a few abbreviations on the slides. I think I figured out is going to be.
Yeah, sorry.
More on that slide. With that.
Yeah. Where do you want me to go? Oh, this one? Oh, C- is it basically lets you collect test results, right? So we have I can't remember the URL off the top of my head, but we use C- in two places actually for reporting things, but it's not front and center. It's not really obvious. I think the public one is very slow. It's not set up very well, and so I want to reset it up so that it's efficient and fast and has the useful things. But it allows you to see, like, which tests passed, which ones failed, and we have it for all sorts of things that we don't have on GitHub. Like GitHub only shows badges for the things that we test via GitHub Actions, and CDAC shows a lot of things that we test internally, and we just report the results there. So HPC machines.
CI there.
Yeah.
For schemes.
Yeah.
And what's E4S?
That's the software release for like the meta release for all the ECP software. Do you remember what E4 stands for? Yeah.
It's like scale software, scientific software.
Ah. Yeah.
So
Exascale software, yeah. But that releases on a certain schedule. It uses SPAC, and we have to get things released by a certain date in order to get them into their systems so that they can then make the actual release from it. So this is kind of this chain where we have to get things done fairly early in order to get them in. And since the Exascale computing project is ending this year, they're going to have a final release of the software, and then we have to kind of back up. So.
I can't remember, are you still supporting auto configuration?
Yes.
Yeah, your intention is to continue supporting that?
I would like to get rid. I'd like to only have one build system, because having two build systems, you wind up, especially as your testing gets more complicated, you have to reinvent the wheel, and you have to come up with solutions that work in both. And we have a bunch of hacks and weirdness to try to do this. Like the way that we do warnings is we have input files that we parse and jam into whatever is appropriate for that system. And so all of that stuff is a lot to maintain. I would prefer to not. And also, it's just even in terms of tests running, right? You have to double up on all your testing stuff. So it's not ideal. And I would like to get rid of it. Yeah, I would love to. I'm afraid that as soon as I do that, like the people who use the auto tools are going to come out of the woodwork and scream at me, and I'm going to have to hide under my desk, and it's not going to be good. But there are things that I think that we still have some parity issues. There are some things I think we need to clean up in CMake before we can make that change. But I would like to. That is the thing that maybe by the end of 2024 we'll see. But yeah, and I might kick that, because that's kind of a big change for people to absorb. I may kick that to the next major release of HDF5. That we'll keep the auto tools moving along. And I would like to do that across our products, right? HDF4, same thing, just get rid of the auto tools.
The biggest issue with this is the testing result, because you really do not find if it fails, it's missing. You make person who tries to find the error missing. So if this problem is not solved, it's just.
Yeah, I find that well, it depends. I mean, if you're developing a POSIX system, the auto tools maps better to a POSIX layout. But there are some advantages, right? Because when you build stuff with CMake, like everything in CMake is an actual built and linked executable, and you can just run it in GDB. If you want to do that with what you just built with the auto tools, you got to know the libtool hack, right? And it's like there's all this like stuff, right? That like the auto tools is weird.
Yeah, but everyone looks at that.
But I mean, everybody knows it. That's great if like we're just basically like, here's the user base now, and it just moves like a balloon through time, and there's no new people that fill in afterwards. That's great, but that's not how we want this to be. We want this to be accessible to everybody, and everybody doesn't want to have to go Google the libtool trick. Yeah, exactly, right. Like, yeah,
I think it would be good to formally offer some deprecation.
Yeah, I tell everybody every time I go to a conference, but yeah, I think, well, as we get close, right? And I think that first there is some CMake cleanup that we need to do. And then I think that as we get, I'm not planning on having a new major release of the software or definitely not next year. So unless like something really important came along that required us to break the API and release a new version. But when we get close to that we will notify people. Yes.
Just a quick question regarding build systems. I'm eagerly following the progress on cross-compile support, specifically from x86, macOS to M1s. And if I look in Flutter Forge and everyone's package scripts on my own to deploy it, it's going to be a big
So yes.
on the roadmap somewhere.
Yeah, cross-compiling, right? So one of the things that I've done over the past, just a couple months ago, I went through all the build stuff, at least for the auto tools. And I think the CMake stuff works better for this. But I went through and added in defaults and stuff like that. And then one of the things that I did that has not made it into 114 yet is I removed I removed the type checking for floating point stuff into the actual library startup. So that's in develop now. And so it's cross-compiling with develop is much easier than it was in the past. And so all that H5 detect junk and the make loops are all gone, right? So that's all gone and cross-compiling is so easy. But, however, comma, so there's always a but. The NAG Fortran compiler, when you build with that thing switched on, there's something that it does that makes floating point exceptions kill your application. I have not had time to look into this, but it does it. And so the NAG Fortran compiler, when you build with it, everything fails because it's gonna, at least on like x86, I think it tries to, or AMD 64, whatnot. It tries to introspect some floating point stuff and it barfs, and then the library dies at startup. So until I fix that issue, or if we tell the NAG Fortran to just decide to not support NAG Fortran anymore, which I don't think we can do, I can't push it to 114. I hope to have it in 114.3. That's one of the highest priority things because everybody wants to cross compile. It's a heterogeneous world now, and we need to support that. And I got it just close, so close. That is my most satisfying pull request ever. was when that got merged in. I was like, yes.
Love it.
Anything else? we feel your pain, right? We know it's been 25 years. I've listened to people yell at me for like 15 of those. Like we're trying to fix that stuff. Next is like Windows Unicode. That's like slide number 3 is I know that drives people with benchtop instruments completely bananas because it makes internationalization impossible in like India and China. And so we're trying to fix that. Anything else?
You mentioned the swimmer on the first slides.
VFD swimmer. Oh yeah, so we have an alternative implementation. It's a swimmer, single writer, multi-reader. I just kind of mentioned it as an aside. It allows you to have one writer and then a bunch of readers. It's very common. Like if you've got a synchrotron and it's spewing out data, you want to know, am I looking at a protein crystal or am I looking at salt? You want to see it right away, so you want to analyze the data that's coming off the instrument. And so we have this thing working, but it only works in limited context. It only works if you've pre-created all your stuff like your data sets, and now you're just spewing into a data set. But if you want to have arbitrary swimmer, then that's a little harder. And we have a different implementation that is more at the VFD level. And we were hoping to get that into the 114.0 release. It just didn't quite make it in. And I think it just needs a couple of passes over it. And then hopefully we can get that in. I just haven't had the spoons to go and do that without the other stuff that we have going on. Right. Like when I'm like VFD swimmer, cross compiling works, like I gotta pick and choose.
Will that be parallel way? Parallel way. No,
Present, this will never be seen. VFD swimmer depends on the working schedule. At present, the main problem is not actually. It should be made so the contributions. Once we have data VFD swimmer can go in parallel, needs a real severe reduction.
And the parallel page buffer is also close to the top of my list of things to fix. Get working.
So for the mobile, for the remote people, the comment was that VFD swimmer doesn't work in parallel, but it can work as soon as page buffer works in parallel. Is that?
Yep.
Yeah.
Anything else? Okay, I'll turn over to Neil.
Well, this opens up. I'm Neil Fortner. I'm the chief software architect for HDF5 at the HDF group. All right, so I'm going to be talking about some recent additions to the HDF5 library. I got 3 features, so I'm going to cover them pretty quickly. Unfortunately, I don't have slides on the onion VFD that Dana mentioned, but if people are interested, maybe we can do a call the doctor on it or something. Or we can talk about, you know, later today or later during the conference. All right, so the first feature is multi-data set. Matthew mentioned this during his talk. So multi-data set is basically, so many applications will want to perform IO on multiple data sets at once. You know, you might have a data set for temperature and another one for pressure or something like that. And so with the you know API that's been around since the beginning of HDF5, you have to do that one data set at a time. So you write your pressure data set, then that goes out and it finishes, it comes back, then you go and you write your temperature data set and so on. But since 1.14, and this feature has actually been in development for a very long time, but we finally finished it up and released it in 1.14. We have new API calls that allow you to batch these writes or reads together into a single API call. And besides just being convenient, not having to make multiple API calls, that also allows the HDF5 library to intelligently you know, present the entire IO operation to the lower IO layers and potentially improve performance because of that. So we talked about virtual file drivers earlier today, but just as a review, is basically a virtual file driver sits under the native HDF5 vol, and the HDF5 library passes it, you know, write this many bytes to this length in the file, or read this many bytes from this location in the file. Things like that. And we're going to be talking about extensions of that in a little bit. All these 3 features are somewhat interrelated. So here's, but the one exception to that is MPI-IO, which can take non-contiguous IO operations. Again, before the other feature I'm about to talk about. So let's go over a quick example of MPI-IO that will kind of show the motivation for multi-data set. So imagine that you're trying to perform IO on 2 data sets. Each of these data sets has 4 chunks. You want to select the first 3 columns of each chunk. So it looks like this. So the red squares are selected, and the chunks are, what are they, 5 by 10. And so for independent IO or for non-parallel IO, you know, legacy non-parallel IO, what's going to happen is, you know, because you can only pass an offset, single offset in length to the virtual file driver. So it has to basically go and for each row in each chunk, it has to do one call for each one of those. So you end up with 40 total calls for this selection. So, you know, it's only 3 times better than if you did 1 IO for each element. And we have a couple schemes that have been around for a while in parallel IO to improve on this. So multi-chunk IO, it goes and creates an MPI data type for each chunk. So then that looks like this. You pass the first chunk to the file driver, the second chunk, and third chunk, etc. So you end up with 8 calls. Then we have the linked chunk IO, where it creates an MPI data type that spans all the chunks in the data set. And so then when you do that, it first operation, it selects all the chunks in one data set and creates a large MPI data type that spans all those and passes that down to the MPI file driver. Then, you know, but because there are 2 data sets, you still have to do 2 operations. So we want to improve on this. And for multi-data set, we create an MPI data type that spans all the chunks in all the data sets. So you select all of them at once and pass it down to the file driver in a single operation. So the APIs that allow this are up here is very similar to the existing HRD read and HRD write, but they're the multi versions, and you can see that all the most of the parameters have these array things. So, you know, and then you have this count parameter, and that determines the lengths of the arrays. And, you know, you can look up the the reference manual for them to see the details, but it's pretty simple. If you pass a count of 1, then it reduces to being the same as the regular HID read and HID write calls. And so we have a couple benchmarks. Here's just kind of quick benchmarks. We didn't spend a whole lot of time finding better benchmarks, but so here's one case where using, if I try to use a mouse, it advances a slide. So you can see that with the before multi-data set, the write was extremely slow, and then it got much better when we switched to multi-data set. And this one, in this case, actually, the read got worse. So, you know, we're being honest. You know, it's always up to you to tune your parameters and stuff. You have a question?
The best case, that was possible before the multi-write, or just not use it? You know, you walked us through a set of cases that you could construct.
Right.
But it just wasn't multi-data set.
These are collective, so they're not. It's not the first one. It's not the row by row. I suspect it's linked chunks. So probably the one call for data set, but I'm not entirely sure. I'd have to talk to Scott to make sure. But and the library actually has some code in it now to automatically decide if it's doing linked chunk or multi-chunk. So and then for the independent case, you can see there's no difference, which is as we expect, because if you go to independent IO, then it doesn't do it doesn't build up the huge data type for, even if you're doing multi-data set, it still does it 1 row at a time. Then there's kind of the same thing, just on a different system. And here you can see that it benefits both write and read for the collected case, though not by as much as it helps write for the last one. And again, independent is pretty much the same, which is as we expected. Another quick CG&S benchmark showed 10% or 6% improvement depending on the column size. And I think, yeah, so, support use case. Okay, so so here's what needs to happen in order for this to work. So all ranks need, if you're doing a parallel operation, all ranks need to pass the exact same list of data sets. The selections in the data sets can be different, but it has to be the same list of data sets. And you can select no elements if one rank isn't doing anything for a certain data set. And all the data sets have to be in the same file. We're not trying to build a MPI data type across files. And each data set can only be present once in the list. I tried to make it work with it being in there twice, but it just gets very difficult with trying to sort chunks. And if the selections overlap on a single chunk, it's just too much. And selection IO, which we're about to talk, is fully supported. And if you want the full, the full 1 MPI data type for the whole thing, then you need to be in collective mode. Obviously, none of the data sets can have data filters or compression, and the data sets have to be contiguous or chunked. And if any of those conditions are violated, it'll still work, but it'll just do, iterate over data sets 1 at a time. Yeah. Type conversions. You think type conversions breaks multi-data set? Yeah, no, actually, yeah, that was one thing I took out of this list because type conversions are supported now. And you can do, yeah, I'm going to talk about that a little bit later, but yeah, it's not highlighted because it's not a limitation anymore. So maybe I guess maybe I should have highlighted that, but it is mentioned in the later slides, and that was a limitation not just with multi-data, it was with any collective IO. But did you have a question, Rick?
You said if any of those are violated, process in 1 data set at a time.
Right.
Pass back any error that lets you know that it's doing that, or does it just fall back to the same?
The question was if is there any feedback if it falls back to non-multi-data set IO? So In this case, yeah, I don't think there is one for multi-data sets specifically, unfortunately. But so collective is obvious. If it's not collective, it's not going to do the thing. So for data filters and compression, we're working on implementing that. Contiguous and chunked. Yeah, I suppose there would be room for an introspection routine for this one. There isn't one for this right now. But I think that's the only case, the non-contiguous or chunked is the only case that would break multi-data set. Once we get the filters and compression fixed. Mark, you have a question?
Another thing. Yeah, the rise, the type, the data type that needs to be constructed.
Mm.
Responsible for constructing that and defining the
Who's responsible for constructing it?
HDF5 color or HDF5 the timing results, that includes the construction of that.
The question is, who's responsible for constructing the MPI data type, and does the timing results include the construction? The first answer is that the library handles that all internally, same as it has before. And for the second question, yes, the timing results include everything, including construction of the data type. So, John?
A very low level question. Is the construction of the
Yeah, so that's one I'm going to cover in a later slide, but yeah, I might as well touch on it now. So the question is the construction of the MPI data type done in the VFD layer or higher up? So with 1.14.2, we've implemented and made the default for it to be constructed in the VFD. But we still do have the code for it to be constructed higher up, but we're hoping to remove that soon. Yeah, I think there were a few cases like trying to switch between multi-chunk and linked chunk. We weren't sure if we need to re-implement that, or if it's okay to just always go to linked chunk. So that's why we haven't moved it yet. So any other questions? I think we've questioned that. All right. All right. So now I'm going to move to selection vector IO, which I think has been mentioned a few times, but now I'm going to cover it in detail. Well, much detail as I can. Pretty much already out of time. So we need to have, how much time do we need to leave for other things after this talk? It ends at 5. Okay. All right. I gotta hurry up. Okay. So I mentioned, I've been talking about for multi-data set, you do all this fancy stuff, but you still rely on it being the MPIO driver, right? In order to pass the non-contiguous selection, because the existing virtual file layer interface only passes an offset in length and a single buffer. So we want to extend that so that other file drivers can take advantage of, being able to operate on more complicated data selections. And so, right now it's effectively like the independent or naive case that I showed before, where it's just one row at a time, even if you do multi-data set, unless you're using the MPIO driver. The MPIO driver uses a special undocumented internal property where the library checks to see if it's the MPIO driver, and if it's using that specific driver, it makes the data types and it stuffs it in the property list and passes it down, and then the MPIO driver knows to check for it. But you can't really use that with other drivers, and so we want to open it up. So we've added new selection vector IO callbacks in the VFD struct, along with the machinery and the library to pass that information instead of just iterating over contiguous blocks. So vector IO is one option. It's this conceptually the simplest. It's basically you just take these lengths and offsets and buffers and vectorize them. So you have a count parameter and then an array of addresses, size, and buffers, and also types, which isn't as important, but we don't have time to talk about that now. And then same for the right. And then selection IO is like that, except we're passing an array of offsets and HDF5 selections, data space selections. So if you look at the HDF5 H5S API, you can see how to define a selection within a data space that will tell you, which elements are selected for IO and which elements aren't. And then also the element sizes, because each element might be 4 bytes or it might be 64 bytes or who knows. And then of course buffers. And so this allows for non-regular or for regular selections like like we showed before, where it's just like columns. This allows it to pass it in a much more compact form than enumerating every single row. But for non-regular selections, it might not be as big of a win. And supported cases are, it supports multi-data set. It's fully integrated with that. So you can have multi-data set code will build up a list of selections across all the different data sets. It supports type conversion. We'll talk about that in a little bit. In order for it to actually get down to the VFD, it obviously needs to be supported by the VFD. And the MPIO VFD now supports selection IO since 1.14.2 and is on by default. Before it supported vector IO and it was off by default. And it needs to be a compact or contiguous data set. I believe it'll work with virtual data sets, but it'll iterate over one source data set at a time. And except for parallel IO, it can't use data filters as compression. It has for 1.14.2 has been vector IO has been implemented for compression, parallel compression. And you can't use a chunk cache, a sieve buffer, or page buffering because cache is just it kind of defeats the purpose, I guess, in some ways. Although we can maybe improve performance a little bit by implementing vector IO for just to the cache and from the cache. And we also have this API for turning it on and off, and that's kind of a best effort. So if you request it's on, but like one of these things prevents us from turning it on, they'll still be off. And we do have introspection routines for this to allow you to know if it actually turned or to let you know why it didn't turn on. And we'll have an introspection routine soon for if it turned on or off. John? Oh yeah, that's chunked or contiguous. Thank you, John. Yes, that slide is supposed to be must be chunked or contiguous data set. All right, and type conversion is supported with selection vector IO, and this also allows type conversion with collective IO, which is a new thing that wasn't possible before. It's new in 1.14.2, and so that can potentially greatly improve your performance for your parallel application. But in order for it to work, the type conversion buffer and the background buffer, if you need one, needs to be large enough to hold the entire IO. Otherwise, we disable selection IO. And we realize that that can be a limitation for many applications. So to mitigate this, we've also implemented in-place type conversion, which is where we do the type conversion in the user's buffer. And so that, removes the extra memory buffer, memory burden, as long as you don't need a background buffer, and as long as you meet these conditions that I'm about to talk about. So for in-place type conversion to work, the memory type cannot be smaller than file type, and the memory selection for each chunk or contiguous data set needs to be contiguous, so it can't like be strided across the memory selection. And if you're trying to write and you want to use in-place type conversion, you need to be aware that it's going to wipe out anything in your write buffer. So the content after you make the write call, the contents are undefined. So you can't use it if you want to reuse that buffer. And it's off by default because obviously we pass a const qualified buffer. And if we do in-place conversion, we're violating that const qualification. And if you want to turn it on, there's this API to turn it on here, HOP set modified write buff. And in 1.14.2, we've also extended in-place type conversion to work with the legacy, existing IO. So you can play around with that too, and it may improve performance, especially if you're doing a large IO that needs type conversion, and you're not allocating a large buffer, because that way it can read the whole thing in instead of just reading a buffer size at a time. So any questions on selection IO? Right. So yeah, this is kind of it's mostly like under the hood mechanism to enable other things, but I think it has a lot of potential. All right, and so now last thing I'm going to talk about is subfiling. And so subfiling VFD is a virtual file driver that allows HDF5 to sort of shard a single HDF5 file across multiple subfiles. And it can be used in parallel. It's meant to be used in parallel, and allows sort of an end-to-end mapping of parallel processes to subfiles. And so again, it stripes sort of like a RAID array or something like that. Defaults to one subfile, so per node, and 32 megabyte stripe size. And it's trying to find the middle ground between convenience of a single shared file and the scalability and performance of the file per process. So hoping to get most of the performance of file per process without so many files, basically. And so the way it works is it uses a set of IO concentrators. So there's a diagram a little bit, but it's so each of the I'll just go through this thing. So each rank has talks to so each IO concentrator has a certain number of subfiles, and each rank talks to its different IO concentrators. So and the subfiles are sort of assigned round robin across all the IO concentrators, and then each, when you're doing IO, the IO concentrator VFD forwards its request to the appropriate IO concentrator. So there's the IO concentrator VFD that runs on the compute node, and the IO concentrator that runs on the IO node. And there's also stub files, configuration files, and of course the main sub files. So the current architecture, there's a subfiling VFD that manages sort of the bookkeeping, and then the IO concentrator does the actual routing of the data. And again, so some subset of the ranks are used as IO concentrators that do the actual IO. So here's the diagram again. You see each rank has a stack of a library, then the VFD, then the two nested VFDs, subfiling running on top of the IO concentrator. Then the IO concentrator gets those requests, and then it talks to POSIX, then down to the actual file system. So here are the API calls to enable this: HIP set FAPL subfiling and get FAPL subfiling. For the details, you can look at the documentation. I've cut those slides out. And here's some quick performance results. So you can see this is time, so lower is better. And so purple is independent, blue is collective, and green is subfiling. So for this case, it's at least an order of magnitude, looks like almost 2 orders of magnitude faster. And again, this is, in this case, y-axis is flipped, it's bandwidth. So subfiling is again much faster, and it scales well with the number of ranks, as you can see here. IOR, and it's been available basically since 1.14.0, and it was also in 1.13.2. In order for it to work, it needs to HD5 needs to be built with parallel. You need a C11 compiler, and you need to call MPI init thread from your application, and you need your MPI implementation needs to support MPI thread multiple. You have a question?
IO concentration only happens within collected by the light bulbs, or is it happening across all the IO activity going on? What are the early and
so the question was the was the coordination happening only in HID read or HID write, or was it happening on everything? Is that, yeah, so I think, so it's a VFD, so it doesn't, I don't think it tries to distinguish between HID read and HID write versus other things. So is any data that comes through, it goes through the subfiling system and then gets shunted to whichever subfile it belongs in based on its offset. So yeah. And also this subfiling uses vector IO, so that's how it's related to the other things. Any other questions? We had we were supposed to have like a free form session at the end of this, but we only have 4 minutes left. So
You mentioned that the subline updated, so all of the rest of the constitutors is that
the question is, has the subfiling VFD been updated so that IO requests to the IO concentrators use vector IO? And I believe so, but I'm not sure because I haven't actually worked on subfiling. You'd have to ask Jordan to be, yeah. Yep.
Yeah, so Neil, the subfiling uses vector IO for everything currently, but it doesn't use selection IO, and we want to update it at some point to do that as well.
You hear that?
Yes.
Right. Thank you.
Any plans to update the choose operations?
Are there plans to update subfiling to support collective operations?
Yes, there's plans to do that at some point. They're not very formal yet, though. At some point in the future, though, there are plans to do it.
And I believe to do that, one of the things that's on at least my wish list is making it easier for third-party VFDs to be parallel. Because right now it's tied specifically to the NDIO VFD. So we would need to work on that for the subfiling to be really parallel or collective.
Right. One of the things that was fixed in HDF5 was to allow VFDs to be able to support collective metadata IO by switching the library to pass those down with vector IO instead of passing down a MPI derived data type that VFDs can't interpret. But there's other parts of the library that need to be fixed, like collective chunk filling, for example.
Right. Thanks. Anything else? Oh.
Are the subfiles independently editable or do you have to?
Yes, are the subfiles independently openable or do you have to go through the master? So I think you can use DD to stitch them together. I know.
Right. So the subfiles are essentially by themselves, they're not valid HDF5 files. They're just data from the file striped according to the stripe size across the files. So the only way to read them directly is to use the subfiling VFD. But as part of these slides, there's a tool that we created called H5 Fuse, which uses DD to stitch those files back together into a valid HDF5 file.
Yeah, unfortunately, I cut that slide for time, but yeah, I can send you that slide if you want. Anything else, Mark?
Well, I'm curious. If others have made this observation, I've made this observation in the past that more functionality portion of the library looks more and more like a application level file system at some level. And so I'm just kind of curious, has a lot of people ever talked to you about, hey, we got to try to implement your subfile thing on our IO node, in other words, somewhat internally to our system as opposed to having this run essentially on top of level.
The question is, have Luster or anyone ever tried to ask if they can implement subfiling in their file system instead of us implementing an HDF5? And I haven't heard anything about that. But
I think they know that they get file library table.
Yeah, I know. So I don't know of any of the file system folks wanting to do that, and I would have to ask Scott on this, but I do know that there's a particular HPC application that he works with that have already implemented basically the same thing as subfiling at their level to get around this same kind of problem. Because they use HDF5 as their backend, but they basically do subfiling type aggregation before they write out to HDF5. And so I guess this handles it at the middleware layer. And then I haven't heard any news of file system people talking about this yet. But I'm sure some people have considered it, but maybe not implemented it.
I think if we tackled it, I would flip it and ask Mustard to expose some rating kind of interface with an IOPO, and then we would just leverage that. And then it would be a normal looking file to Mustard.
Maybe that one.
Yeah. Yeah.
Anything else? Okay, thank you.